Hi, this is Mrs. Clark, and welcome to my video on an intro to transformations. We're going to go over a couple definitions in this video, just about some basic transformation vocabulary, and talk about some notation as well. So on your graphic organizer here, let's fill in together what a transformation is. Now, you've probably heard of a transformation before and practiced at least identifying a few of the different transformations. But a transformation can be a change in position, size, or shape of a figure. A change in the position, size, or shape of a figure. Okay. And so some vocabulary that we use when we talk about different transformations, and this is generic for all transformations that we'll talk about, are the pre-image. So the pre-image is the original figure. The OF, original figure. And then the image is basically the new figure, the figure after the transformation. Okay, and there are different ways that we label these two things. The pre-image gets labeled with letters, just general letters. So I'm going to write label ABC, because when I go to label the image, I have to show A has now transformed to become something different, and B is transformed to become something different. So the way we label them in the image is we label them A prime, which is like almost like a little apostrophe, B prime, C prime, etc. So you might want to make a note here that that little 1 is a prime. It's called prime, like Optimus Prime. It means that it came as a derivative from the original. We're going to use that in our notation. So when we're actually doing the transformation, we're going to label original points with letters and then the prime version for the image. All right. So a rigid motion is a transformation that preserves size and shape. A transformation that preserves size and shape. So that means that the pre-image and the image have the same shape and the same size. So things are going to be looking exactly the same, just it's going to be moved, turned, flipped, something like that. All right. So whenever we're talking about a rigid motion, that's when the pre-image and the image are congruent images. So remember the word congruent, you've heard that in middle school. That means that they have the same size and the same shape. All right. Then we have this little arrow here, this notation arrow that we use. It means goes to, or another term for that can be maps to. And we use that in our notation when we talk about coordinates from the original point, the pre-image, and then where do they go to, what do they look like in the image. So here's an example of a notation. We can say the coordinate x, y, whatever x was, whatever y was, it maps to a new x where that new x is twice the old x, and that new y is the old y plus 3. So we're going to be doing some work with this kind of notation today. But this notation would say my old x is doubled and my old y we add 3. And that's how I get my new point. So we're going to talk about how to do some of that notation in this unit for each of the different types of transformations that we're going to do. All right, so let's fill in this little paragraph at the bottom, kind of explaining things. So a mapping, we use the word maps to when we talked about the arrow. So a mapping is a correspondence between sets of points so that each point in the first set corresponds to exactly one point on the second set. In algebra, a mapping is called a function. So you learned about functions last year in algebra, and that is considered a mapping where one thing goes to one place. In isometry, it's probably a new word for you, is a rigid transformation where the distance between any 2 points in the pre-image must be the same distance between those points on the image. So that means however far apart they are in the pre-image, they're going to be the same distance apart in the image. So everything is staying in the same relation to another point. Therefore, the pre-image and the image are congruent figures. So remember the word congruent, same size, same shape. And we'll talk about that more later on in this unit. And isometry also preserves angle measures. So there's only one blank here, but we'll stick in the word measures under angle. So not only are the sides the same length, the points are the same distance apart, but all the angles actually remain the same as well. And that's what makes them really congruent figures. So remember, congruent figures, you could take one, put it on top of the other, and they'd match up perfectly. All right, so this is your page that you're going to cut out. You can cut like right along the edge here, fit it right onto your page, title it Intro to Transformations, and go ahead and glue that in your notebook. Thanks for watching.